Welcome to Brain Vision.
So continuing on with our work around physical chemistry, we're going to be taking a look at vapor pressures again here today. So we've looked at a few podcasts that have explored the same sort of content, and so we're not really looking at anything new here. So what we can take a look at first is the vapor pressure of water at 90 degrees Celsius. We can get that from tables that we have available to us, so we don't need to actually figure that out, luckily enough, and that is 5 to 5.76 millimeters of mercury. So we can determine the partial pressure of water in air at 50% relative humidity. H tau is equal to Pi divided by P star T times 100. We solve for Pi. That is 262.88 millimeters of mercury. So the dew point is the temperature at which the vapor becomes saturated. So Pi is equal to Pi star T, temperature of the dew point. So we can look up the vapor pressure of water tables for the following temperatures. So we have P star for 72 degrees Celsius, 254.6 millimeters of mercury. And we've got 73 degrees Celsius. So that is 265.7 millimeters of mercury. So we interpolate to find the more precise temperature to match the equilibrium vapor and pressure. So we have P star 72.7 degrees Celsius equal to 262.88 millimeters of mercury. And the dew point at initial conditions is 72.7 degrees Celsius. So the degree of superheat is the difference between the dew point and the overheating starting temperature. So we've got degree superheat 90, take away 72.7, 17.3 degrees 17.3 degrees Celsius. So at 90 degrees Celsius, the air has 17.3 degrees Celsius of superheat. So we can take a look at part B now. So we can calculate the number of moles in 1 cubic foot of feed gas, assuming ideal gas. So our N is equal to 0.0336 kilomoles. So we can calculate the mole fraction of water in the air at 1 atmosphere, 90 degrees Celsius and 50% relative humidity. So what we can take a look at is Yi is Pi divided by P. Yi, we sub in the values, 0.3459 moles of water per moles total air at initial conditions. So we can take a look at the vapor pressure of water in different tables for 25 degrees C. So P star of water, 25 degrees C, I'll tell you what it is to save you having to search for it, 23.756 millimeters of mercury. So we can calculate the mole fraction of water saturated in saturated air at the final temperature. Got Y final is equal to P final divided by P, which is 0.03126 moles. So the moles condensed is N total. Yi take away Yf. That is equal to 10.6 moles. Final part here. So if the volume is variable, 90 degrees Celsius, air will begin to form a mist when our pressure is equivalent to the vapor pressure of water, which is 90 degrees Celsius. So we can look up the saturation pressure for 90 degrees Celsius in our tables. So we get P star 90 degrees Celsius. I'll tell you what it is to save you searching. 525.76 millimeters of mercury. So the mole fraction of water at those conditions from previous equation, we have Y initial is equal to 0.3459 moles. We can calculate the total pressure using Rayleigh's law. So P is equal to P star multiplied by T over Yi, we get 1520 millimeters of mercury.